This is Jun2005 A21 Module 4, a simple harmonic motion question, and it's question 4. In the part C of this question, you should answer in continuous prose. You will be assessing the quality of your written communication. State the characteristics of the acceleration of a body moving in simple harmonic motion. So this is again is about the acceleration. Its acceleration is directly proportional to its displacement and is always directed towards a fixed point. And you could also, if you wanted, include A is proportional to minus x. But that'll get you your 2 marks there. A body oscillates with executes simple harmonic motion with a periodic time of 62.5 milliseconds. The maximum velocity of the body is 3.01 meters per second. Show the amplitude of the oscillation of the body is 0.030. So the first thing that you know there is that t is equal to 62.5. Now it's in milliseconds, so just be very careful about that. It's by 10 to the minus 3. And therefore you can work out a value for omega. It's 2 pi over 62.5 by 10 to the minus 3. And that comes out as 100.5 radians per second. Right, and then V max equals x naught omega. So x naught is V max over omega. And V max is 3.01 and omega is 100.5. And so x naught comes out to be 0.0301 meters, but I'll just leave it 0.03 or roughly, and thereabouts. So that's fairly straightforward to do. Making use of the given data and quantities calculated, state the equation for the displacement of the body. So we'll just assume that it has got a sign in its equation. So x is equal to x naught, we're told, is 0.03, or we've just calculated, and it's a sine of omega is 100.5 and t. I'll just write the x naught sine omega t underneath so you can see where that's coming from. Part C, describe, write an account of the variation with time of the amplitudes of motion vibrating with simple harmonic motion and damped harmonic motion. Use the gap below to draw any sketch graphs needed. So it says write an account of the variation with times of the amplitudes of motion in simple harmonic motion and damped. Use the graph below. So if we draw a wee graph, use the gap below. We draw a wee graph. If we were going to draw simple harmonic motion, if you're going to draw it, you need to just make sure that your graph is nice and even looking. I'm just marking this off every couple of centimetres here, so I'm going to have a nice even looking graph, and I just make a wee dot up here for my maximum amplitude or maximum displacement. Okay, so if this is undamped motion, what we'll do is like that. Bit wobbly, sorry about that. You'd do this in pencil, obviously. Be much neater than mine. Okay, so this is amplitude or displacement in time, and then I'm going to draw in green what would happen when it's damped. So we'll start off more or less the same, but each time it's going to get a little bit less. This is a fairly heavily damped way I'm drawing this. Okay, so that's the damped motion there, the green one. Okay, so then it says to explain that, so undamped amplitude is constant, and you could say C graph If you've your graph clearly labelled, there's no reason why they wouldn't give you the full marks for your graph. And then damped A decreases with time until it reaches, it stops moving, or A is equal to 0. So there's where your 3 marks are coming in there. Now you would write that out properly in continuous prose because they've told you they're awarding marks for that.